This video is about calculating molecular formulas. Now you'll notice your notes are a little different than what I have up here, and so I would like for you to make the following corrections in your notes, especially when we're talking about the example. The molecular formula is different than your empirical formula that we talked about yesterday in that it gives the actual number of atoms present in the compound. If you remember, the empirical formula is the lowest whole number ratio of atoms in a compound. So the molecular formula will tell us exactly how many atoms really are present in the compound. Now this sentence is a little different than what's in your notes. The example that I'm giving you are two compounds that have the exact same empirical formula, which is CH, but one of them is benzene, which is C6H6, and these subscripts did not come through. So this should be C6H6. Benzene is a liquid, and acetylene, which is C2H2, is a gas, but they both have the same empirical formula. So the empirical formulas are nice for giving us the chemical composition and the percent composition of a compound, but the molecular formula really makes the compound what it is. And the way that you find the molecular formula, these problems will sound very, very similar to the problems that we did previously for empirical formulas, except that they must give you the molar mass of the compound. And the only way that we can find the molar mass of the compound is to determine it experimentally. And so the example that we have is we have succinic acid is a substance produced by lichens. Chemical analysis indicates that it is composed of 40.68% carbon. So we have 40. Oops. Oh, my stylus is not working very well. Let me try my finger. Here we go. That's a 40.68% carbon. 5.08% hydrogen. So we have 5. 0.08% hydrogen, and 54.24% oxygen. So we have 54.24% oxygen. And it has a molar mass of 18.01 grams per mole. And you're going to have to determine the empirical and molecular formula for succinic acid. Now usually your empirical formula sometimes can be given. If it's given, then you get to skip step 1. But if it's not given, like in this example, then you have to do step 1. And step 1 is to find your empirical formula. And we did these previously. So when we have percentages, we assume that we have a 100-gram sample. And that makes the math a little bit easier. So this gives us 40.6, oops, there should be a 0 there, 40.68 grams of carbon and 5.08 grams of hydrogen and 54.24 grams of oxygen. And if you remember, the first thing that we need to do is convert our grams to moles. So we have this guy, we have 1 mole up here, and we have 12.01 grams. And this will give us let me scroll over a little bit. Let me see how to do this. Do this. See if I can scroll over. Oh yeah, here we go. Perfect. 3.387 moles of carbon. And our molar mass of hydrogen is 1.01 grams, and we have 1 mole here, and that gives us, let me erase this, there we go, and we have 5.030 moles of hydrogen, and for oxygen we have 16 grams is 1 mole, and that gives us 3.39 moles of oxygen. And remember, the next step for making empirical formulas is to divide by the smallest number, which happens to be the moles of carbon. So this is our smallest. And I apologize for the writing. My touchscreen isn't working that great, so I'm having to write with my finger. But we're going to divide everything by this. So this is going to give us 1. When I divide oxygen by 3.387, I get something very, very close to 1. And when I divide my hydrogen, 3.387, I get 1.48, which is very close to 1.5. Now remember that these mole ratios now become our subscripts for our empirical formula. So what we're going to do is our empirical formula then is C1H1.5O1. And we do not like to have, ooh, I did not mean, I thought that would scroll, but I guess not. So we don't like to have these decimals. So remember, if it ends in 0.25, your multiplier is 4. If it ends in 0.33, your multiplier is 3. If it ends in 0.5, your multiplier is 2. If it ends in 0.67 or close to it, your multiplier is 3. And if it ends in 0.75, your multiplier is 4. So we have something that ends in 0.5, so our multiplier would be 2. And so our empirical formula is C2H3O2. And that is our empirical formula. So we are going to use this now to calculate the ratio between the two molar masses of our empirical formula so that we can find our molecular formula. And so we have carbon, and that would be 2. So we need to find our molar mass of our empirical formula. So that's 2 times 12.01, which gives us 24.02. And we have hydrogen, which is 3 times 1.01, which gives us 3.03. And we have oxygen that had a subscript of 2 times 16, which gives us 32. And when we add those all up, we get a molar mass of 59.05. And so now what we have to do is we take our experimentally determined molar mass, which was, if you look at the problem, it says it was 18.1, and you divide it by this molar mass right here, which is 59. Let me erase that. Here we go. 59.05. When we plug that into our calculator, we get a number, we get a value of 2. Now, something that is a little bit different from empirical formulas. This is a chance to check your work. It will catch a few mistakes. This answer right here, this must be a whole number. If you get a decimal, or it must be close to a whole number. Like if it's 0.9 or like 0.98 or 1.98 or 2.01, those are close enough to whole numbers. So that way you can round. But if you get something that's probably 1.75, 2.68, I would double check your math. Make sure your empirical formula is correct. Make sure that you've done the division with your molar mass, your experimentally determined molar mass, and your molar mass of your empirical formula. Because this number must be a whole number. And the reason why is that we take this answer that we got and we're going to multiply all the subscripts in the empirical formula by that number. So our empirical formula is C2H3O2, and we're going to multiply all that by 2 to get a molecular formula of C4H6O4, and that is your molecular formula. Now this is the longest type of problem that you will probably get for determining molecular formulas. Sometimes your molecular formula calculation might look something like this next slide. Okay. This slide is pretty straightforward. What they've done is you should probably do the happy dance inside because they've already given you your empirical formula. So you don't have to do step 1. It's already been done for you. So once you have your empirical formula, you find your molar mass of your empirical formula, which we're trying to find the molecular formula for a compound that has a molar mass of 78 grams per mole and an empirical formula of CH. So our molar mass here is carbon is 12.01 and hydrogen is 1.01, and that gives us a 13.02. And then we're going to take this number and divide it by our empirically determined molar mass, which is 78. So we'll take 78 and divide it by 13.02, and we get a number that is not exactly 6, but is pretty darn close to 6. So then our multiplier would be 6, so we would have 6 times CH, which will give us C6H6 for your molecular formula. And that's all there is to it for these types of questions. I think probably one of the hardest things in these is still to be able to calculate your empirical formula. And then you have to remember that you need to put the given molar mass on the top when you do this. Let me get a different color here. When you do this division here, that this number that's been given, your molar mass, has to be in the numerator. Your empirical formula, the molar mass of your empirical formula, which is right here, this always goes in the denominator. Okay? I think that's it. And if you have any questions, you can post them on Edmodo.